Hey everybody, today we are going to look at, we're going to look at section 4.7. So if you would get out your note sheets, on the back of page 37, go to the back of page 37, and we are going to talk today about the inverse trigonometric functions. Do not be afraid. The inverse functions are pretty easy. There just are some rules that you have to know. So I'd like you to make a note here of these rules, and then we're going to begin the problems. Now, first of all, this notation, I'm looking at the first problem. This notation, this problem, literally says to me, find the angle whose sine is 1/2. Now, the first rule is, if this number is positive, if the number in the problem is positive, I want you to look for the angle always in quadrant 1. No matter whether it's a sine or a tangent or a cosecant, it doesn't matter to me. You look in quadrant 1 if this number is positive. If that number is negative, we'll have some other rules. But our first rule is, if this number is positive, as it is in question A and B and C and G, all those have positive numbers, we're going to look in quadrant 1. So now we're going to draw a picture of a triangle in quadrant 1. And it is going to be part of our butterfly bow tie. Always, always, always. We want the sine of that angle. And remember, it's always the angle at the origin inside the triangle. So this is the angle we're talking about, and we want his sine to be 1/2. So that means opposite over hypotenuse is 1/2. You should recognize this triangle. It is a special one. This is the √3. What angle is across from the 1? If you said 30, you are right, and that is the answer to the question. Your job was to find the angle whose sine is 1/2. 30 degrees has a sine value of 1/2. Well, that wasn't bad. Let's try B. B says, find the angle whose cosine is √3/2. That's a positive number. So I told you a minute ago, I hope you haven't forgotten already, if the number is positive, we're going to draw it in quadrant 1 every time. This time, here's our angle now, this time we want the cosine to be √3/2. So cosine is adjacent over hypotenuse. You should recognize those numbers and know the other side is a 1. So once again, that's our 30-degree angle because 30 is across from the 1. So the answer to this one is also 30 degrees. No, the answer is not always 30, but it is so far. Okay, let's try the next one. All right, I'm going to write it one more time, and then I'm going to stop writing out what it says. This question says, find the angle whose tangent is √3. It's a positive number. You are going to draw it in quadrant 1. Now, it might help you to think of that as a fraction, root 3 over 1, because you know tangent is opposite over adjacent. So if you think of that as root 3 over 1, you can see where the opposite side is root 3 and the adjacent side is 1. And that would make the hypotenuse 2. This is the angle you're looking for. It's across from the root 3, so it is a 60. 60 is across from the root 3, so the answer to the question is 60 degrees. Well, this is pretty easy so far. Here comes a tricky one. It's got a negative number. So now we have to learn the negative rules. Remember, if this number is positive, you are always going to draw your picture in quadrant 1. If this number is negative, and it is a, so let me see, how am I going to say this? Number is negative. You will draw it in quadrant 4 if it's a sine, a cosecant, or a tangent. You'll draw it in quadrant 2 if it's anything else. So if it's a cosine, a secant, or a cotangent. Now you're thinking to yourself, Ms. Ford, how am I supposed to know that? You just need to memorize it. You need to memorize that if this number is positive, you're going to draw it quadrant 1 every time. If it's a negative number and it's a sign, then it belongs in quadrant 4. So I will draw my butterfly bow tie in quadrant 4. Now this is the angle I'm looking for. Notice it's going down. It will be a negative angle. Let's see if we can figure out how big it is. The sine is -1 over root 2, opposite over hypotenuse. You should recognize that triangle and recognize that's a 1 right there. How big is that angle? You're right, it's 45 degrees. So the answer to this question is -45 degrees. -45 degrees. Next problem, this is E. I'm looking for the angle whose cosine is -1/2. The angle whose cosine is -1/2. That's going to be in quadrant 2. How do I know that? Because it's a negative number and it's an inverse cosine. That happens in quadrant 2. Hopefully you have this written down in the margin somewhere. Cosine is adjacent over hypotenuse. Hopefully you recognize a right triangle with a 1 and a 2. This would be a root 3. This angle is 60 degrees because 60 is always across from the root 3. Be careful. This is your answer. Remember, you have to start measuring here. Always, always, always. So if this is a 60-degree angle and this is 180, what will this be? How big will that be? Well, it went almost to 180, but it stopped with 60 to go, so that angle would be 120 degrees. If you draw 120, it's another 60 before you get to 180, right? So the answer is 120. The tangent is -1. The angle whose tangent is -1. I'm going to go ahead and make a fraction out of that again. -1 over 1. Got to figure out which quadrant to draw it in. It's an inverse tangent, negative, so it goes in quadrant 4. How do I know that? I got my chart over here. Inverse tangent, quadrant 4. The tangent is -1/1. You recognize that. That's a √2. This angle is 45. It's going down, so the answer is -45 degrees. Now we're back to a positive. Positives are easy. Nothing to remember about positives except they're always in quadrant 1. The angle whose sine is √3/2. Opposite over hypotenuse. This has to be a 1. It's one of your special triangles. All these will be. Unless you're allowed to use a calculator. These are all no calculator problems. This angle is 60. That is the answer to the question. It's a first quadrant angle. 60 degrees is the angle whose sine is √3/2. Now we want the angle whose cosine is -√3/2. So which quadrant will we draw that in? Why, we will draw it in quadrant 2, because that's where the inverse cosine is negative, in quadrant 2. Cosine is adjacent over hypotenuse, so this side is a 1. This is the angle you need to label. It's across from the 1, so it must be the 30. 30 is not the answer. The answer is this angle, which is, yep, 150. Answer to the question is 150 degrees. From here to here is 150, because this is 180 and it's a 30 in between them. I is different because it's got a 0, and anytime there's a 0, gang, you have to look quadrant, you have to look on an axis. It says the tangent, the angle whose tangent is 0. So you're going to look around your circle here. We're going to look up here. This is where we look at if the numbers are positive. And for the tangent, we look in quadrant 4. So for tangent problems, we're always looking either in quadrant 1 or quadrant 4, which means I can kind of ignore this side of the picture. Remember, you always look in quadrant 1 if it's positive, and then you look in quadrant 4 if it's negative. So all your inverse tangent problems are going to be looked in these two quadrants. Where does the tangent equal 0? Well, remember, tangent is y/x. So if you look right here, x is 0 and, x is 1 and y is 0. If you put y/x, you get 0/1, which is 0. This angle is your answer, and that is an angle of 0 degrees. That's 0. Now, what if we would have looked up here? X is 0 and y is 1. What happens when you do the tangent up there? Well, you put y/x, that would be 1/0. Is that 0? No, it is not. It's undefined. This is the answer to the question. The tangent of 0 is 0. Let's try another one. That's a little confusing, I know. Let's try the next one. Find the angle whose sine is 0. Find the angle whose sine is 0. All right, so anytime it's a 0, I'm going to look on an axis. Now, I'm not going to look at the whole circle. This is a sine problem, so I look in quadrant 4 sometimes, and I look in quadrant 1 sometimes. So I'm only looking at those two quadrants, and I've got these points. I'm having a hard time here. I look at those points. Sine is y over r. Now r is 1. If I put y over r here, y over r would be 1 over 1, 1 over 1, y over 1. Here, y over r would be 0 over 1. And here, y over r would be negative 1 over 1. Which of these answers is the one I want? This one, because it says I want the sine to equal 0. So once again, the answer to the problem is this angle, which is 0. You could also say 360, but nobody ever does, so 0 is the best answer. All right, you're going to get a chance to practice some of those tonight, and we will definitely go over them on Monday, so do not worry if it doesn't come crystal clear. Give it your best shot. Go back and rewatch this video if you think it will help. What I need you to do now is to look at page 38, because we've got a couple of other kinds of problems here to look at. I don't want you to freak out when you look at it. It is not anything to freak out about. It's actually kind of easy. Let me read this to you. Or actually, I'll write down what it says as I read it. It says, find the sine of the angle whose tangent is 3/4. Find the sine of the angle whose tangent is 3/4. Now, do you see how this number is positive? That means when I draw this angle, I will draw it in quadrant 1. Here it is. Its tangent is 3/4. So I will do the Pythagorean Theorem. This is not one of my special memorized 30, 60, 90 type triangles. But I do know, because I've seen this one before, that when I do the Pythagorean Theorem, this will be 5. 3 squared plus 4 squared. Now, what do I want to know? I've drawn this picture. I drew a picture of this right here. That's a picture of it. What do I want to know? I want to know what's the sine. Well, look there. Here's the angle. What's the sine? Opposite over hypotenuse. The answer is simply 3/5. See how easy that is? You found the sine of the angle whose tangent is 3/4. The first thing we did was draw the angle, and then we found its sine, opposite over hypotenuse. Let's try the next one. Oops. I will write this out one more time. We're doing problem B now. This says, find the cosine of the angle whose sine is 5/13. Find the cosine of the angle whose sine is 5/13. So I'm going to draw a picture of that angle. And because that's a positive number, I will draw it again in quadrant 1. The sine is 5/13. opposite over hypotenuse is 5/13. If you do the Pythagorean Theorem, x squared plus 5 squared equals 13 squared, this will work out to be 12. So now I've drawn a picture of the angle whose sine is 5/13. What do I want to know? I want to know the cosine of that picture. The cosine would be adjacent over hypotenuse, or 12/13. So the answer is 12/13. Now we're going to find the tangent of the angle whose sine is -4/5. We're going to find the tangent of the angle whose sine is -4/5. Find the tangent of the angle whose sine is -4/5. All right, so the first thing I'm going to do is draw a picture of that angle. It's a -4/5, so I am not going to draw it in quadrant 1. It's an inverse sine negative, so it's going to be drawn in quadrant 4. The sine is -4/5. Do not be confused by that. Sine is opposite over hypotenuse. You know how to label your triangles, opposite over hypotenuse. If I do the Pythagorean Theorem, x squared plus 4 squared equals 5 squared, this turns out to be 3. And it is a positive 3, because I go right and down. What do I want to know about that angle? I want to know its tangent. What's the tangent of that picture? Opposite over adjacent, the answer is -4/3. Hope you're getting the hang of this. It really isn't too bad. Find the cosine of the angle whose tangent is 2/3. That's a positive number, so I will draw it in quadrant 1. Once again, let me read this problem to you. Find the cosine of the angle whose tangent is 2/3. The tangent is 2/3. That means opposite over adjacent is 2/3. Now for the first time, I'm going to get a radical, because 3 squared plus 2 squared equals r squared. 9 plus 4 equals r squared. So r is going to be the square root of 13. By the Pythagorean Theorem, r is the square root of 13. There is a picture of this angle. It's a beautiful picture. Now, what's its cosine? What's the cosine of that picture? Adjacent over hypotenuse, 3 over root 13, which you know you have to rationalize, multiplying top and bottom by root 13 to get 3 root 13 over 13. That is your answer. Okay, 2 more real quick. Hopefully the tape won't run out of the video here. The space quickly. We'll find the sine of the angle whose cosine is root 7 over 4. And we'll find the tangent of the angle whose cosine is 3/4. Okay, so let me read this one again to you. This is E, page 38, part 2, E. We're finding the sine of the angle whose cosine is root 7 over 4. So first thing I'll do is draw a picture of that angle. Notice it is positive. That means I will draw it in quadrant 1. Remember, we draw all positives in quadrant 1. The cosine is root 7 over 4. So I'm going to put root 7 here and 4 here because cosine is adjacent over hypotenuse. I need to do the Pythagorean theorem to find this side. So I'm going to do my theorems. Here we go. Root 7 squared plus x squared equals 4 squared. 7 plus x squared equals 16. X squared equals 9, so this number is the square root of 9, which is 3. Notice it is positive because we're going right and up, so everything is positive. Now what do I want to know about that picture? I've drawn the picture, I've labeled all the sides, everything looks great, but I need to know the sign. Sine is opposite over hypotenuse. Here's your angle, always at the origin inside the triangle. Opposite over hypotenuse, the answer is simply 3/4. Last one, here we go. Once again, we have a nice positive number, so we're going to be looking in quadrant 1. This number is positive, we'll be looking in quadrant 1. The cosine, this says, find the tangent. Find the tangent of the angle whose cosine is 3/4. So this angle has a cosine of 3/4, adjacent over hypotenuse. Well, I need that side, so I'll say 3 squared plus x squared equals 4 squared. 9 plus x squared equals 16. X squared equals 7. So x equals the square root of 7. Now I need the tangent of that angle. Tangent is opposite over adjacent, so that will be root 7 over 3. Opposite over adjacent. Okay, you got a homework assignment. Go ahead and help each other. Get started on that. Good luck, and I will see you on Monday. And by the way, here's your weekend hug. See ya.